Okay, 5 says that no elevator fires a gun horizontally and the bullet leaves with a velocity of 306 kilometers an hour. So that's Vx. Now I've already converted that to meters per second because I might need it, so it's 85 meters per second. And then it's going to have to fall 3.4 meters to the ground. And it wants to know how long is the bullet in the air. Well, we have d equals 1/2 at squared plus vit. It has no initial vertical velocity, so that can go away. So t is going to be the square root of 2d over a. So that's the square root of 2 times 3.4 meters over 9.8 meters per second squared. I took the square root of that, and when I took the square root of that, I got 0.83 seconds. So there was my time in the air. Part B said, what is the final vertical velocity of the bullet when it hits the ground? So Vf equals Vi plus At. It had no initial vertical velocity, so A is 9.8 meters per second squared. Numbers with every number having a unit. Multiply those two together, and I found out that it had a Vf of 8.13 meters per second. And then it wanted to know, C, how far did it go out horizontally? Is that what it asked? Yes. What is the range? Range is always dx. And dx is equal to vxt. So you can see that I took that 85 meters per second and I multiplied it by 0.83 seconds. And when I did that, I got range to equal 70.6 meters. So there's number 5. All right, let's move on to number 6. Number 6 says, rows of corn throws a banana at an angle of 40 degrees to the horizontal, and it goes up 40 meters, and we want to know what is the range. Well, come on, pen. So a lot of people will tell you, well, just do the tangent and you can get that answer, and then I would have to give them a big fat X, because the only way the tangent works is if these two sides change in direct ratio, and they don't. This is accelerated, this is not. But what I can do is I can figure out that Vf squared equals Vi squared plus 2AD, and I can find out all kinds of stuff. I can also say that the distance that it falls down is going to be 1/2 GT squared plus VIT, and on the way down that would be 0 because it would have no initial vertical velocity at the highest point. So 40 meters would be 1/2 of 9.8 meters per second squared, T squared. So I can say that it fell for, when I did that, I got 2.86 seconds. That's also the time that it went up. So now I can say Vf equals Vi plus At. So Vf is going to be 0 at the highest point. Vi is unknown. A is a negative 9.8 meters per second squared. And T is 2.86 seconds. So I can find find Vi, and the initial vertical velocity that it had when I did it was 43.6. No, hang on. Having some trouble here. Need to make a fix. Okay. So that's 0 meters per second. And Vi is going to be the sine of 40 degrees times V, plus there's my negative 9.8 and my 2.86 seconds. So I did that math and I solved for V, which is this hypotenuse right here. And when I got that hypotenuse, I got 43.6. So now I'm finally getting somewhere. So I want dx. dx is equal to vxt. So that's going to be the cosine of 40 times 43.6 times the total time, and the total time is 2 times 2.86, so that's going to be 5.72 seconds, I think. So when I did that, I got dx to equal 191 meters. Okay, number 7. So on number 7, I have a can of Dr. Pepper that's kicked horizontally at 1100 meters per second. I don't know what kicked it. That's an incredible speed. So there's my 1100 meters per second. That's horizontally, so it's going to do something like that, and gravity is going to pull it down. Its initial vertical velocity is 0. And the cliff itself is 12.4 meters high. So we want to know how long is the can in the air. T is equal to question mark. Well, we have D equals 1/2 AT squared plus BIT. This is 0. This is 12.4 meters. And the reason that's 0 is it has no initial vertical velocity. Gravity is 9.8, and it's positive because it's coming back to the Earth. So I figured out that it's going to take it 1.59 seconds to get to the Earth. And then part B says, where does it land from the base of the cliff? So dx. Well, dx equals vxt. dx was 1100. T was 1.59 seconds. So when I multiplied vx times t, I got 1750 meters. Okay, and then finally number 8. Number 8 has some troglodytes. So here's their cliff. Here's their neighboring cliff. This is 42 meters of separation. That's the dx. And they're going to shove this rock, a bomb, off the cliff. And they shove it off at Vx equals 6 meters per second. And it falls down like that. And they want to know basically what's that distance right there. Okay. So, and I could have made this cliff be the same height. Doesn't really matter. So I'm going to say, well, dx equals bxt. So 42 meters divided by 6 meters per second means that my bomb is going to fall for 7 seconds. And then I could go to d equals 1/2 at squared plus bit. And since I'm talking vertical now, that's 0. Gravity is 9.8. T is 7 seconds. So it's going to fall 240. And I think mine actually came out to be 240.1, but it doesn't really matter. Meters. All right. 5 multiple choice. I don't remember 5 or 6 word problems. Very doable. So please study.